Welcome dear learners. We are continuing Unit 1 Chemistry as a Science Discipline and Scientific Analysis. In the present module, we are discussing mean, median and average deviation in quantitative chemical analysis. In this module, we are focusing on quantitative chemical analysis, mean, median of data, average deviation and problems based on the concepts shown here. First of all, quantitative chemical analysis. What is meant by quantitative chemical analysis? You all familiar with the fact that chemistry is a science branch which give extreme emphasis to various kinds of analysis. The analysis can be broadly classified into two categories. They are quantitative analysis and qualitative analysis. In qualitative analysis, we are finding out the components present in a compound. However, quantitative analysis deals with the quantification of amount of substance present in a sample. That is, we can define quantitative chemical analysis like this. Quantitative analysis in chemistry refers to determining the amount or concentration of a substance in a sample. This about the definition of quantitative chemical analysis. Now, the quantitative chemical analysis involves precise measurements and is essential in various fields including pharmaceuticals, environmental testing and industrial processes. In quantitative chemical analysis, accurate and precise measurement of data is critical. This implies that we have to acquire exact data for smooth result and accurate result in quantitative chemical analysis. Statistical tools like mean, median and average deviation are used to analyze and interpret data which ensures its reliability. So, reliability is very important as far as the statistical approach of quantitative chemical analysis is concerned. So, tools like mean, median and average deviation are very important in quantitative chemical analysis. First of all, we are focusing on mean. The mean is the average value of a set of measurements. Suppose you are appearing for a series of examinations and in every exam the total mark is fixed as 50 and in 5 examination you got different scores. So, whenever you have to finalize your internal assessment marks or CA marks, we have to take the average of all the tests. How you are taking the average? So, you performed 5 examinations, you got 5 different marks and the total mark is 50. So, the 5 marks are added together and divided by total number of tests, that is equal to 5. You will get the average of your exam score. So, the mean is the average value of a set of measurements. The mean can be calculated by using the expression shown here. Mean, it is abbreviated as x bar, where x is a set of measurement or xi is a set of measurement, sum of xi divided by n. And here xi is individual measurement and n is the total number of measurement. Now let us come back to the previous example what I mentioned. You have approached 5 different examinations, 5 series of examinations, and in every examination you got different marks and each mark is abbreviated as xi and you appeared 5 different examinations and the total number of examination is equal to 5. So, here you can say that n is equal to 5. So, mean can be calculated by using the expression mean x bar is equal to sigma xi divided by n. Here n represents total number of measurements. Now, the mean represents the central tendency of repeated measurements and helps in identifying the most probable value of a quantity being analyzed. This point is highly significant as far as the analytical significance or statistical significance of mean is concerned. Now we can exemplify the concept of mean in quantitative chemical analysis by taking an example. For this illustration, we are taking determination of molarity of sodium hydroxide solution. You are familiar with this concentration term molarity. Molarity represents number of moles of the solute present per liter of the solution. And suppose you imagine a chemist performs 3 titrations. Titrations means volumetric analysis. You are familiar with the volumetric analysis. Volumetric analysis is a quantitative analytical method in which you are finding out the concentration of a solution by performing titration. So, in the present example, a chemist performs 3 sets of titrations to determine the molarity of a solution of sodium hydroxide solution. So, the situation is like this. You are provided with sodium hydroxide solution whose concentration is unknown, and you are performing titration, and you performed a titration thrice, that is you performed 3 times titration, and the data obtained is like this. The first time you got the value 0.0987 molar. In the second iteration, you got the value 0.0992 molar, and in the final set of titration, you got the value 0.0990 molar. That means you got 3 sets of values, and we are going to discuss the concept of mean with respect to these 3 values. Now, to calculate the mean molality, we have to perform calculation like this. That is, we have to add these 3 values, namely 0.0987, 0.0992 and 0.0990. You will get a total value. You have to divide it with 3. The 3 represents 3 sets of data you are having. So, total, the sum of all these values divided by total number of data, that is equal to 3, and the result obtained is 0.0990 molar. This simply emphasizes the fact that during 3 times of analysis, you got the average concentration of the solution as 0.0990 molar. Now, another statistical procedure which is very important as far as the quantitative chemical analysis is concerned. This is nothing but median of data. We are going to details of the median of data. The median is the middle value in a sorted data set. So, median simply implies the middle value in a given set of measurements. For this, you have to arrange all the obtained data in a sequential order, and then we have to pick up the middle value. In the coming few slides, we are discussing about median and exemplify the concept with some suitable illustrations. If the number of measurements is even, the median is the average of the 2 middle set of values. Suppose you are having 8 set of measurements, and these 8 set of measurements are arranged in series order. Since the middle value is not there, since the total number of measurements is even, then the middle values between 4 and 6. So, 4 and 6 are the 2 central values. You have to take the average of the values at position 4 and at position 6. This we can illustrate in coming few slides. Now, the median is useful for data sets with outliers as it less affected by extreme values compared to the mean. Here you heard the term outlier. What do you mean by the term outlier? This term outlier is very frequent as far as quantitative chemical analysis is concerned. You are measuring some concentration by volumetric analysis, or you are measuring some concentration of a given solution by using spectrophotometric method. Suppose you are taking a series of measurements, namely 5 or 6. Suppose in certain cases there is a chance that one or two values may be far away from the lower value or the higher value. Such far deviated value in a set of analysis is taken as the outlier. So, detection of outlier is very important. There are so many statistical procedures other than median are there to find out the outliers. Now, this is important in eliminating the influence of random errors or anomalies. You are familiar with various kind of errors. Errors simply indicate that the deviation of experimental value from the true value or accepted value. In the last certain modules, we learned seriously about various kind of errors, rectification of errors, random errors, etc. And this median is a statistical procedure, and it is important in eliminating the influence of random errors and some anomalies associated with the measurement. Now we are illustrating the concept of median by taking an example. The example selected is determination of melting point of a compound. You are familiar with the concept of melting point. It is the temperature at which a solid material converted to liquid, and during the determination of the melting point of a compound, the following temperatures are recorded. These are the temperature values obtained by an analyst when he recorded the melting point of a compound. The values obtained are 192.1 degrees Celsius, 182.4 degrees Celsius, 192.0 degrees Celsius, 185.0 and 182.3 degrees Celsius. You are here having 5 sets of data, 5 sets of temperature with you, and we are going to pick out the median of this analytical data. And first of all, to perform a scientific way to calculate the median, in the first step, we have to arrange the data in an ascending order. That means the above temperature values has to be arranged either in ascending order or in descending order. In many cases, we are taking for convenience, we arrange the data in ascending order. So, whenever it is arranged in ascending order, the data are appear like this. 182.0 is the last value and 185.0 is the highest value. So, these are the arrangement of data in the ascending order. Now, in the second step, we have to identify the middle value. The middle value is nothing but median. Here it is clear that you are having 5 sets of data. So, it is very easy to pick up the central value. The central value or middle value in this analysis, it is very clear that this value 182.3 appears in the middle region. So, these are 5 set of data which is arranged in the ascending order. You have to pick up the middle value. Since this is odd number of data, it is easy to pick up the central value. The central value is 182.3, and it is very well clear that the median of the melting point of 5 sets of analysis is 182.3 degrees Celsius. So, to identify the median, you have to first arrange the data in the ascending order and then pick up the middle value. If the total number of measurement is odd, then easy to pick up the middle value. If the total number of measurement is even, then you have to take the center 2 values and the average of that 2 value will give you the median of the data. Now, another statistical procedure we are discussing here is average deviation. We have discussed 2 kind of statistical procedures like mean and median, and the third analytical or statistical procedure we are discussing here is average deviation. First of all, what is meant by average deviation and what is its significance. The average deviation, or it is otherwise called mean absolute deviation, measures the dispersion of data around the mean. So, average deviation works on a central data. The central data is nothing but mean. So, average deviation simply gives us the dispersion or distribution of data around a central value, that is the mean. The average deviation can be mathematically calculated by using this expression: sigma modulus of xi minus x bar divided by n. And it is very well clear that xi represents individual measurements and x bar represents the mean of the measurement. So, xi minus x bar simply represents deviation of each measurement from mean. However, here we are taking the absolute value of the deviation, that is, you are not considering the sign, we are considering only the magnitude. So, xi minus x bar is always taken as a positive quantity. So, sometimes whenever you are calculating the difference between the individual measurement and the mean, it may be positive or negative. But you have to ignore the sign, because in average deviation, we are considering the absolute deviation or the modulus, or simply the difference between individual measurement and the mean of the measurement. So, once again it has to be given more emphasis that sum of modulus of xi minus x bar. Xi is the individual measurement, x bar is the average of a set of measurement. Average of a set of total n measurements are here. So, x bar is the average of n measurements. So, in every case you have to calculate the difference first, that is xi minus x bar in each case, and we have to take the modulus, that is only the magnitude we have to consider. So, xi minus x bar represents absolute deviation of each measurement from the mean. X bar is the mean and xi is individual measurement and n represents total number of measurements. In the coming slides, we can illustrate this average deviation by taking suitable examples. Now, average deviation quantifies the precision of the data set. You are familiar with the statistical concept of accuracy and precision. What do you mean by the term precision? You can simply remember the concept of precision. Precision represents the repeatability of a data, of a set of data in repeated measurements. That is simply termed as the precision. You learned about the concept of precision and various ways to express the precision in the past modules. A smaller average deviation indicates more consistent measurement. So, if you take a set of measurements or a set of data and find out the average deviation using the previous expression, and you will get some average deviation value, and for final interpretation you have to take the value of average deviation. It is very well clear that a smaller average deviation indicates more consistent measurement, or simply precision will be high. It is practically valuable in evaluating the repeatability of experiments, or to evaluate the precision in a set of measurements. Now, it is possible to illustrate the concept of average deviation by taking an example. And for the convenience, we are taking analysis of a sample's percentage purity as an example to illustrate the concept of average deviation. A chemist analyzes the percentage purity of a sample of calcium carbonate, that is limestone CaCO3, and obtain the following set of results. The results he obtained are 4 in number because he performed 4 series of analysis, and the values obtained are 94.8%, 95.1%, 94.9% and 95.3%. So we have to find out the average deviation of these sets of percentage purity data. So we have to proceed in a systematic way to obtain the final value of average deviation. For this, we have to calculate mean in the first step. Mean means average of the set of measurements. So, the mean of the given set of data can be calculated like this. Here we are having 4 sets of measurements and you have to take sum of these values and divide with the 4. So, the mean value of the percentage purity measurements equal to 95.025%. Now, in the second step, we have to calculate absolute deviation. Absolute deviation is given by the expression modulus of xi minus x bar. That is, in every set of measurements, you have to obtain the absolute deviation. Take the first data, that is 94.8, and take the difference with the mean value, that is 94.8 minus 95.025, and take its modulus. You know this is a negative quantity, but on taking the modulus, you will get the magnitude as 0.225. Similarly, we have to take the absolute deviation by using other 3 sets of data. So, whenever you are taking the absolute deviation, you will get 4 sets of values for modulus of xi minus x bar. Now, in the third step, we have to calculate the average deviation. The average deviation is obtained by this equation 0.225 plus 0.075 and so on, the whole divided by 4, and the average deviation of the set of measurement is equal to 0.175%. So, in this expression for average deviation, the numerator represents the sum of absolute deviations. What is meant by absolute deviation? It is the modulus of the difference between individual measurement and the mean of the total measurements. So, you can calculate average deviation like this. The small average deviation value obtained here, that is 0.175%, simply indicate that the present purity measurement is a precise measurement. This is because lower value or smaller value of average deviation indicates high precision. Now, practical applications of average deviation in chemical analysis. We are discussing quantitative chemical analysis and various kind of statistical procedures adopted in quantitative chemical analysis, and what are the practical applications in chemical analysis. The mean gives the central value summarizing results. The median minimizes the influence of outliers. The average deviation, which is the most important among these 3, highlights the variability or speed we are discussing some numerical problems based on the concept of mean, median and average deviation. This is your first MCQ. The mean is most suitable for which type of data set? These are the options: data with no outliers, data with many outliers, data with extreme variability, and the final option is random data set with irregular patterns. On careful analysis of these 4 sets of answers, you can arrive at the final answer as option A, that is data with no outliers. So, mean is applicable to a set of measurements which are very close to each other. That is, if there are some outliers, outliers are present in the data, the concept of mean is not suitable. This is the second question. In a set of measurements, 12.1 gram, 12.4 gram, 12.0 gram and 12.2 gram, finally 12.5 gram, what is the median? In order to get to the median, you have to arrange these 5 sets of values in the ascending order and then you have to pick the middle value. These are the options and you have to find out the exact answer to the option, and the answer is 12.2 gram. That is the third option, and we have to sort the data in the increasing order: 12.0, 12.1, 12.2, 12.4 and 12.5, and you have to pick the middle value. The middle value is nothing but 12.2. That is the median of the data set shown here. This is the next question. A chemist measures the pH of a solution 5 times. The values obtained are 7.2, 7.3, 7.1, 7.2 and 7.5. What is the mean pH? So you have to calculate the mean of a set of data, 5 pH measurements. And in order to obtain the mean value, we have to add all these values together and divide it with the total number of measurements. You are familiar with the concept of pH, that is nothing but the concentration of H plus ion present in a solution, and the 5 sets of values are here and the mean can be calculated by using the simple expression. You have to add all these values and divide with the total number of measurement. Total number of measurement is equal to 5 and you will get answer as 7.2. By adopting the procedure, you have to take the sum first, 7.2 plus 7.3 so and so, divided by 5 and you will get to the final value which is round off to 7.2. So option A, 7.2 is the right answer. Now this is another question. Which of the following best describes the purpose of average deviation? To determine most accurate measurement, to identify outliers in data, to measure the spread of data around the mean, and to find the central value of data. On careful analysis of these 4 options, we can arrive at the final answer as C, that is to measure the spread of data around the mean. This point we gave maximum emphasis, and I mentioned the fact that average deviation tells us the dispersion or distribution of data around a central value, that is nothing but mean. So your answer is option C. This is another problem. During a gravimetric analysis experiment, a chemist obtains the following weights. This is in grams. The weights are 1.004, 1.006, 1.005, 1.007 and 1.003. What is the average deviation? The question is about finding out the average deviation of a set of data given here. So you are having a total of 5 set of data and you have to proceed in a systematic way to find out the final average deviation. So for this we have to take the average of these values, then find out absolute deviation, then take the sum of that absolute deviation divided by total number of measurements to get to the average deviation. On proceeding in a systematic way, we will get the final value of average deviation as 0.002 gram. So for this you have to calculate mean first, that is sum all the values, divide it with the total number of measurements. You got mean or x bar as 1.005 gram. Then you have to calculate the absolute deviation from each set of data, and these are the absolute deviation values, and absolute deviation divided by total number of measurement will give the average deviation. So the average deviation of these sets of values equal to 0.002 and your answer is option B. Now, in which scenario is the median more appropriate than mean. These are the options. All data points are equally distributed. The data contains extreme outliers. The data is normally distributed. The data is symmetric. This is your answer. Option B, the data contain extreme outliers. In this scenario, where there are some outliers, the technique median is more appropriate. Now, another question. A chemist records the boiling point of a liquid and the values obtained are 100.2 degrees Celsius, 100.4, 99.8, 100.1, 100.3. What is the median of boiling point? These are the set of measurements and you have to pick up the correct value of median from the options given, and this is your answer, that is nothing but 100.2 degrees Celsius, which is obtained by proceeding in the way. First of all, we have to sort it in the increasing order. This is the increasing order of the data set. 99.8 is the least value and 100.4 is the high value, and then you have to pick out the middle value. The middle value of these set of measurements, here again there are 5 set of measurement and it is very easy to pick up the middle value, and the middle value is 100.2 degrees Celsius. That is the median of the set of measurements, that is the boiling points. Now, a data set has a mean of 15 and average deviation is 5. What does this indicate about the data? Look out these options. The data is highly precise. Most data points are within 5 units of the mean. The data has significant outliers. The data is inaccurate. Most of the data points are with 5 units of the mean. This is another problem. Which formula is used to calculate average deviation in a data set? These are your options, and on careful analysis it is clear that option C is the right answer. That is, average deviation can be calculated by using the expression sum of modulus of xi minus s bar divided by n. So, your option is option C. Now, this is about the last MCQ of this module. Which statistical measure is least affected by outliers in a data set? These are the statistical procedures as the answer. Option A, mean. Option B, median. Option C, average deviation. And option D, that is nothing but a range. Which of these is least affected by the presence of outliers in a given data set? Your answer is option B, that is nothing but median, which is least affected by outliers present in a set of measurements. That all about the present discussion on 3 statistical procedures: mean, median and average deviation. That all about this module. Have a nice learning experience. Thank you.